For decades, Pluto occupied a special place in our imagination. Discovered in 1930, it was celebrated as the ninth planet of our solar system and became a familiar part of science textbooks around the world. But in 2006, everything changed. The International Astronomical Union reclassified Pluto as a dwarf planet, removing it from the official list of planets. To many people, the decision felt like a demotion. Pluto was suddenly viewed as a small, frozen object drifting in the darkness far beyond Neptune. Interest in the distant world faded, and it was often dismissed as little more than an icy relic left over from the formation of the solar system. Yet science has a way of overturning assumptions. In recent years, observations from powerful telescopes and data collected by NASA's New Horizons mission have transformed our understanding of Pluto. What once appeared to be a cold and inactive world is now emerging as one of the most fascinating and mysterious objects in the solar system. Instead of a frozen wasteland, scientists see a complex world with active geology, a dynamic atmosphere, and the possibility of a hidden ocean beneath its icy surface. The story of Pluto is no longer about what it lost when it stopped being considered a planet. It is about what we are beginning to discover. One of the most striking features on Pluto is a vast region known as Sputnik Planitia. Shaped like the western half of a giant heart, this enormous basin stretches for hundreds of kilometers across the dwarf planet's surface. It is primarily composed of frozen nitrogen ice, creating a landscape unlike anything found on Earth. At first glance, Sputnik Planitia appears calm and motionless. However, scientists believe it is actually one of the most active regions on Pluto. The surface shows signs that the ice is slowly flowing, almost like a glacier. Over time, these movements reshape the landscape and erase older impact craters. The relative lack of craters in this region suggests that it is geologically young. In planetary science, a younger surface usually indicates recent activity. This discovery was surprising because Pluto exists in one of the coldest regions of the solar system, where temperatures can plunge below -220 degrees Celsius. How can such a distant world remain active? One possible explanation lies beneath the surface. Many researchers believe Pluto may contain a hidden ocean of liquid water buried beneath a thick shell of ice. Although sunlight reaching Pluto is extremely weak, heat generated inside the dwarf planet could help maintain liquid water deep underground. This internal warmth likely comes from radioactive elements slowly decaying within Pluto's rocky core. The concept may sound surprising, but Pluto is not the only icy world suspected of hiding an underground ocean. Several moons in the outer solar system, including Europa and Enceladus, are believed to contain subsurface oceans as well. These discoveries have dramatically changed how scientists think about potentially habitable environments beyond Earth. If Pluto truly possesses a hidden ocean, it would mean that liquid water can exist even in regions once thought too cold and inhospitable to support it. The possibility of liquid water naturally leads to one of the most intriguing questions in science: could life exist there? No evidence of life has ever been found on Pluto. However, scientists know that life on Earth can survive in some of the most extreme environments imaginable. Microorganisms have been discovered deep underground, near hydrothermal vents on the ocean floor, and in regions exposed to intense pressure and cold. Because of these discoveries, researchers no longer believe that sunlight is an absolute requirement for life. If a stable source of liquid water exists beneath Pluto's surface and if suitable chemical ingredients are present, some scientists argue that simple microbial life cannot be completely ruled out. Of course, this remains purely speculative. At present, there is no proof that Pluto hosts living organisms. Nevertheless, the possibility continues to inspire scientific curiosity and future exploration. Another reason Pluto has attracted so much attention is its remarkable geology. Images returned by New Horizons revealed mountains made of water ice, towering several kilometers high. Unlike Earth's mountains, which are shaped by tectonic activity and erosion, Pluto's icy peaks exist in an environment where water behaves more like solid rock. Scientists also identified vast plains, deep fractures, and unusual surface patterns that suggest Pluto has experienced significant geological change throughout its history. These features indicate that the dwarf planet is far more dynamic than researchers once expected. Adding another layer of mystery is Pluto's largest moon, Charon. Pluto and Charon form one of the most unusual planetary systems in the Solar System. Because Charon is relatively large compared to Pluto, the two bodies orbit a shared center of gravity located in space between them. In a sense, they behave more like a binary system than a traditional planet and moon arrangement. This unique gravitational relationship may influence both worlds. Tidal interactions between Pluto and Charon could have generated heat in the distant past and may have played an important role in shaping their evolution. Charon itself is a fascinating object. Its surface contains deep canyons, enormous fractures, and strange reddish deposits near its poles. Some scientists believe these red regions formed when gases escaping from Pluto traveled through space and became trapped on Charon's surface, where chemical reactions gradually transformed them into darker materials. The connection between Pluto and Charon demonstrates that even small worlds can interact in surprisingly complex ways. Pluto's atmosphere is equally intriguing. Although extremely thin compared to Earth's atmosphere, it contains nitrogen, methane, and carbon monoxide. When ultraviolet radiation from the Sun interacts with these gases, it creates complex organic molecules that contribute to Pluto's reddish appearance. These compounds, often called tholins, are particularly interesting because they may resemble some of the chemical building blocks involved in the early development of life. While tholins themselves are not living organisms, they provide valuable insights into the kinds of chemistry that can occur throughout the solar system. Pluto is located within the Kuiper belt, a vast region beyond Neptune filled with countless icy objects. Most of these distant bodies remain largely unexplored. If Pluto possesses hidden oceans, active geology, and complex chemistry, scientists wonder whether similar processes could be occurring on other Kuiper belt objects as well. This possibility has expanded the search for potentially habitable environments far beyond the traditional boundaries once considered suitable for life. Despite everything we have learned, Pluto remains full of unanswered questions. Does a liquid ocean truly exist beneath its icy crust? How long has its geological activity been occurring? What processes drive the movement of its glaciers? And what secrets remain hidden beneath its frozen surface? Answering these questions will require future missions. While the New Horizons flyby in 2015 provided humanity's first close look at Pluto, it lasted only a brief period. Scientists hope that future spacecraft may someday orbit Pluto, study its atmosphere in greater detail, and investigate the structure of its interior. Such missions could revolutionize our understanding not only of Pluto but of distant icy worlds throughout the solar system. Today, Pluto stands as a reminder that scientific discovery is often filled with surprises. Once dismissed as a remote and insignificant object, it has become one of the most intriguing destinations in planetary science. The farther we explore, the more we realize how much remains unknown. Pluto challenges our assumptions about what makes a world active, how planetary systems evolve, and where conditions suitable for life might exist. Far beyond the orbit of Neptune, in the cold darkness of the outer solar system, Pluto continues to keep its secrets. And with every new discovery, it reminds us that even the most distant worlds can change the way we see the universe.